Hey folks, it's been a little while since I've done one of these, so I figured I was motivated by a really nice little refactor that I just paired with Page on. So I thought I'd do another little like lunch and learn loom specifically on TypeScript union types and a really good use case for them and kind of the benefits of utilizing TypeScript union types. And so more broadly, this is going to kind of follow the trend of leaning on your type system to make impossible states impossible, which is a really cool concept. So to kind of walk through what that means pragmatically, we have our iframe that's rendered in Jira, and there's a bunch of different pages effectively that can be rendered within an iframe. So basically we have all of these different like error scenarios, and then we have okay, actually everything is all good. We're going to render you a bunch of interesting details about a connected Jira project and its request types and the triage channel and request channel and like all of these help specific things via GraphQL. And so this is kind of the top level app TSX of the iframe. You can kind of think of this big like if statement as being like the router. We're stuck within an iframe, so we can't actually use a real router, but this is kind of it. This is how we would do like redirects within the iframe, is setting this top level page state, and then that's going to kind of decide what to render on the iframe. And so basically the refactor that we did is that there is one specific state currently, which is the connected to project, that is only renderable if you've successfully initialized an Apollo client, so you can make GraphQL requests, and you have an integration ID and a Jira project ID. But it's kind of weird that because all of these are pieces of floating disconnected state, there theoretically exists like states that the application could be in where the page state is loading and we do have these pieces of state set. Or even worse, we could have a page state that is connected to project and only one of these has actually been set. And so that's kind of forcing us to do these like defensive checks to make sure that we have everything that's necessary to render. But in the scenario where page state is connected to project, we want to enforce the fact that we have to have these present, because otherwise we'd fall through to this generic error case, but our page state would be connected to project, which doesn't really make sense within like what should be possible for the app to do. And so we can use union types. We can basically graduate what is already a simple union type into a deeper union type to kind of encapsulate that these are the pieces of state that are required for this connected to project iframe page to be rendered. And so there's a couple of ways that we could go about this. So this is currently the page state, which is just a simple string union. Now, if we went a step further, we could have something like new page state, which could have a page, which would be this page state. So it would be that string union. And then we could have some integration ID string and project ID string as like optionals. I think you get where I'm going with this. Now we can, again, this is maybe a step better because we've kind of coupled those pieces of state with the page state, which is what it is, rather than them just being these like floating pieces of React state. We can do one better. We can actually say that in order to go to the connected to project page, you must have both an integration ID or a project ID. Otherwise, you can't even switch into that state to begin with. And so how we can do that is basically by making a object union type instead. So if I were to say the page is loading, and if it's in a loading state, it has no additional parameters, and then we say that, and then hopefully Pretty is going to reformat that for me, and it will. We can copy that into that. Okay, and so I'm going to make one of these simple types for all of our page states that don't require any additional state in order to render. So we've got loading, we've got auth required, we've got connected to project is the one that we're going to skip, we've got JSM free, we've got generic error, we've got Slack already connected, we've got JSM site already connected, and we've got legacy already connected. Okay, and so there's one more of these that is going to have some required arguments, which is the connected to project state. And that state is going to have a non-optional integration ID and a Jira project ID. So we're just going to call this page state, and we're going to hunt down some compiler errors and fix them up. So we can say that anywhere where we were just setting the string, this is now going to be setting an object that has a page value of that string. I'm just going to steal that, plunk that in there, grab you, put that there. And here. Sorry, just bear with me. Okay, so we've hit the interesting one. Now, the first thing that you'll notice is that this won't actually compile. So this is going to tell me that in order to switch to the connected to project state, in order to render that page, you must have an integration ID and a Jira project ID. Now, luckily, we have them right here. We were just setting these loosely connected pieces of optional state at the same time as we were switching into that top level page state. And so we can just forward those through. So we've got our Jira project ID and we've got our integration ID, which we're getting IntelliSense for because Typescript knows that this is the type of page that we're trying to render. And that one is going to be this context.integration ID. Cool. We can blow away those. There is actually one more as well that I'll do while we're here. So this is the only page that is actually capable of making GraphQL requests. We can also encode that into the page state, the same way that we've done with the integration ID and the Jira project ID. So I'm going to use that as an opportunity to codify the fact that this is the only page capable of making GraphQL requests. We can go ahead and get rid of all of these pieces of state. So we now have, I'll keep chasing compiler errors, and we definitely do now want to also forward through the Apollo client. And that should compile. Cool. We'll keep going. Whoops. Let me save that. Do our page. Okay, so now we get to the actual rendering portion. So most of these can just change to pagestate.page. Oops, I don't know what snippet that was. .page. And grab that, put that here. And so this is the other benefit to using the union type, is we no longer have to be paranoid about checking these anymore. So I can add the .page here. These variables no longer exist, so I'm just going to axe them. And at this point, we know that page state is going to have all of the things that we need to render. So IntelliSense will tell us that as well. We have the Apollo client, the integration ID, and the Jira project ID. So I'm going to go ahead and fill those in. Page state. And one more down here. Cool. So what does that actually achieve? Like, there was a lot of moving things around. To what benefit? And so I kind of alluded to this at the start, but it means that we don't have to do as many runtime checks, and we don't have to handle cases that we know with our application knowledge should be impossible. So what I mean by that is things like being in a connected state, but not having an Apollo client, or these IDs that are like, those signify that I am actually capable of being in that state. So we can codify that into the union type. So it basically means that we can get rid of a bunch of like null checking when it comes to actually doing the render method, which is like down here. And it also means that when we're actually attempting to move into that state, we are required to provide the things that are necessary to actually be in that state. So another example of where an object union type could be really useful is thinking about webhook payloads on the back end. So what we really typically see a lot of the time is maybe like an interim step that's close to this. So there might be like a webhook payload, and this might have a payload type or something like that, and it could be a comment updated or an issue updated. And what you'll see really often is that there'll also be optional types on this same blob that are illustrating the webhook payload being in either of these two shapes. So there might be an optional comment ID and an optional issue ID based on whether it was a comment updated or an issue updated. So you can go a step further, and basically whenever you're seeing like a bucket of optional types on like an overarching object type, you should think really carefully about, well, are these actually optional properties, or are they required properties that are only required if the entire object is in a specific shape? So in this case, I would turn something like this into an object union, where if it's a comment updated, we have a non-optional comment ID. And if it's issue updated, we have a non-optional issue ID. And so that combined with TypeScript's like really powerful inference means that if you were to do an if check on the payload type, and you were to say, is it a comment updated? And I'd structured this like a union type like this one here, it would know at compile time that there is definitely a comment ID there, and there's definitely not an issue ID there, versus having to have all of these like paranoid checks at runtime to make sure that the object is in the shape that you're expecting. So that's pretty much it. I hope that was useful or interesting to someone, but I thought that was a really good illustration with this particular refactor on why union types can be super useful for codifying some of our knowledge of the states that the application can be in a way that will prevent you from compiling things that would have otherwise led to bugs. Thank you.